Hi guys, if you're following my channel, you know there are two things which are making me headaches here in my DIY Powerwall. One are these Sun GTIL inverters, and the other one are the DC protective devices. Well, this one I can only fix by a quite big investment. This one can be easily improved. And how? We're going to take a look now. So as you can see now, what I'm using are DC-MCBs. Now again, most of them unfortunately are polarized DC breakers, and this in a bipolar application, which is charging and discharging currents. We have DC chargers here, and here the DC main breaker. None of these MCBs should actually be a polarized breaker. I already made a video about this once. The only one you see here, this is a brand which is manufacturing non-polarized DC breakers, and I had already replaced all the others by this brand, but they all failed within just a few months. And this situation is of course unacceptable, and we are going to talk now what will change. Fuses, they come in many different shapes and forms. And there's also some characteristics you need to consider when choosing a fuse. So if you're looking into the specifications, there are only three main characteristics which are interesting for us. And that is, of course, the rated current. The rated current, you need to choose the way that the fuse will of course not blow when you are using your equipment in a normal way. But it also needs to have a little bit of buffer so that it does not blow if, let's say, the ambient temperature, etc. is changing. So in my case, for my 25 amp chargers, I will use a 40 amp fuse. And for my 20 amp, for example, I will use 32 amps. This is still fine, because what we are protecting here is of course not much overload. All the equipment is protecting itself for this anyway by itself. We want to protect from shorts, etc. The other characteristic will be a very important one, and that is the maximum rated voltage. And in this area you can actually also see a lot of mistakes when watching other videos, because when it comes to DIY, people are very creative. So they are using sometimes fuses which are built for audio equipment, or fuses which are built for automotive applications, and those fuses are typically not rated for very high voltages. You have to be really careful if you're using an automotive fuse or breaker. Those are normally rated for, let's say, 12 volts or maximum 24 volts. If you're going to use these in a 48 volt system, you might get into deep trouble there. And then a very important characteristic is as well the maximum current breaking capacity. This will depend very much also that you're using the correct type of fuse. When you're using DC, you have to use a DC rated fuse. Why is it so much important to use a DC rated fuse when using in a DC system? DC rated fuses are typically built differently inside, because they have to break an arc when the fuse or breaker is disconnecting the circuit. When an arc is stable, nothing will extinguish the arc without an intervention. So taking all this into consideration, we will find out that ceramic fuses are the best way to go. So let me show you what I have chosen for my Powerwall. and later on we will go and build those fuses into the Powerwall. Yeah, so these are the fuses that I got from my Powerwall. Those are so-called solar GPV fuses, but in general these are ceramic fuses. They can go by many different names. They are certified by the IEC 60296-6 standard. That's a high voltage DC standard. That standard for the United States viewers equals to the UL 248-19. Just for the reference here, this guy you might know from your solar combiner box. They are used as string fuses. So the difference between this and the other ones is just the rated current. That's why they are bigger or smaller. So the standard is 10 by 38, 1000 volts. They can go with rated currents up to 32 amps. Then this one, which I need in my Powerwall, is just a bigger brother. It's a 14 by 51 millimeters, also 1000 volts, and they go then from 32 amps up to 63 amps. And everything else then, if you need more amperage, is then this form factor. In China it's called the FDS. In Europe you will then know this by NH00, NH1, etc. So this is then from 80 to 160 amps. I got the 120 amps as the battery main fuse. So then of course you can go higher than that, 200 amps, 300, etc. And it's just the size which will change. When we're talking about the IEC 60269-6 or UL 248-19 standard, this is all about ceramic fuses. What are the advantages of ceramic fuses? So they will withstand higher internal pressure and thermal shock. They have a very high breaking capacity. So in that standard it's minimum 10 kiloamps. But typically it will be somewhere more around 30 kiloamps minimum. So that is when that fuse really have to break at 1000 volts. If you're using it for a nominal 48 volt system, so where we can have voltages maybe up to 60 volts maximum anyway, that breaking capacity would be nearly infinite. So what's else in that standard? The copper contacts of those fuses and holders will typically be silver coated, and the melting element inside the ceramic body will typically also be from silver. When it comes to how much of current a battery pack can deliver in case of a short, there's a rule of thumb. And for lithium iron phosphate cells, that would mean it can deliver approximately 10 times the amount of its amp hours this battery pack would have. So in my case, this battery pack, even it looks so big, because of its really bad state of health, this is a 300 amp hour pack, and this pack would approximately deliver 3000 amps of short circuit current. And those 3000 amps must be broken by the fuses. I'm sure you know how these holders work. You just take the fuse, put it inside the holder there, and then when this cover is pressed in, the fuse will then make contact with this clamping mechanism inside, and we have a very strong and tight contact in there. And of course, like this, you can anytime pull on this handle and disconnect the circuit with the fuse holder. So what have I paid for this? This 14 by 51 fuse holder, including one fuse, has cost me about $5 US. So if you need the fuse only, it is about $3 US, and then you have to add for shipping. And this FDS 160 fuse has cost me around $12 US for the holder and the fuse. And this came directly from China via AliExpress, and the brand which I'm using is one of my favorite when it comes to DC applications. So let's get the installation done. A lot of tools also for a small job. And let me show you my newest toy, a cordless heat gun. I have all the tools from the same company, so I only have a couple of batteries and a lot of different tools, which is great. And the cordless heat gun is especially important for electric jobs, because usually you don't have electricity when you do electrics. And yeah, where do you then get the power for a heat gun, which you of course need for all the shrink tubes, etc. So the main breaker will be removed, of course, and then only on the plus side there will be the NH type fuse. So the negative cable, I had to make a longer one, which will then crimped together with the other. The polarized DC breaker here for the inverter will stay, because inverters only draw the current one way, so this is okay. And these three breakers here for the chargers, they will be replaced by the fuse holders. You can see those are quite bigger. They are 1.5 slot, and yeah, so probably I will have to move everything a little bit to the left there. That's the job. It should be quite straightforward. I just have to make 2 lugs here for these 2 plus cables here, and as I said, the connection on the negative side, and everything else will be just screwed into the existing configuration here. So as I said, the main purpose of this exercise today is remove all this polarized stuff here. Fuses do not care about the direction of the current in the system, so this makes your DC system safer. So just crimping the main battery cable. Yeah, the fuse holder is installed for the NH fuse. I just need to connect the negative pole on the up there, and then this is the biggest part of the job is done. My main cables here on the battery are 25 square millimeters, but I'm only pulling or pushing a maximum of 4000 watts or 80 amps on the system. That is mainly because of the old battery cells. Now let's just remove these breakers here one by one. So the first one will be a 32 amps fuse and the other ones are 40 amps. I have my other compartment on the other side and it's only one fuse I have to put there because there's only one charger installed. Yeah, and that's already it. Let's put the fuses 32, 40 and 40. And now comes the question which I always get asked, because most of you are actually installing this sort of MCBs because they can also be used as switches. The NH fuse, of course, is not really suitable for use as a switch because you need either a special holder or you need a sort of handle to pull out the fuse, but you should never do that under the load anyways. But these individual breakers, of course, these can be used as manual switches. So when you pull the fuse here, there are two holding brackets, one on the up, one on the down, and the fuse is actually pulled out of both of them simultaneously. So it is creating right away a gap of probably around 2 centimeters here or even more, maybe 3 centimeters. So this should extinguish any arc, but this is a manual switch and you should handle this the correct way. And how to do that: if you want to disconnect DC manually, you have to activate the switch as fast as possible, right? So you would go here and pull as fast as you can, and there should be no chance that an arc can be created. And once you shut down every individual circuit, of course, then you can go and pull out the NH fuse if necessary. Yeah, and the job is done. The only thing I can do now, what is left, is putting the NH fuse, main fuse here. So this one is a 125 amps. Now I can connect the individual circuits, turn on the Powerwall, and that should be it. So this was the retrofit from DC-MCBs to fuses, and this should have turned the system now to a much safer one, and I don't need to think about bi-directional currents in this Powerwall as well anymore. As you should know already, I'm not affiliated to any product manufacturer or shop, so you should research the market by yourself, of course. I will leave a link to the store I have used, but I have nothing from it. I'm simply also just a buyer there. This is how I did it, and I think this is a very safe and good way if you're looking for DC fuses for a power application to do it like this. Okay, so I hope you found this video interesting. Please comment, did you as well use fuses in your system? What kind of fuses did you use? And yeah, thank you for watching. Please like the video, subscribe to the channel, and I see you next time.